Okay, so I've kind of butchered this, sort of. Basically, obviously I was talking about putting tape and stuff over these diffusers. That sort of worked, but it kind of, it just, it just looks a bit unfinished. I mean, it is unfinished, but you know, I mean, the tape's falling off. I wouldn't follow this step. I'd maybe find something that's a bit better. I made the mistake of buying foam when I should have bought some sort of wood surface diffuser. Although that probably wouldn't have held up on top of that. Maybe if I got some plywood and stuck it to it, it'd work a bit better. So anyway, hello, because I'm making video. I'm insecure now. Yeah, okay, so the idea was to cover it in tape, so it's somewhat reflective, and it will reflect stuff now instead of just absorbing it. However, it's not ideal. I've also managed to forget my microphone, so you're getting the whole room capture now. I'm gonna shut up and test these, and how I'm doing that is with a reference microphone. I'm going to do multiple different tests for this. Basically, I'm going to have one with the microphone in the middle of the room, so it's getting more of the room itself. One in the listening position, and then obviously repeat that without the diffusers on top and see how that is. And then also do one with just the room itself. I'm seeing what frequencies are being cut by these acoustic panels. This video shouldn't take too long, let's be real. Should only take a small amount of time. But I'm going to let you see how I've butchered this. I mean, like, look at that. I'm flooding the room with pink noise. If you don't know what pink noise is, it is basically every frequency all at once. Yeah. I've removed the diffusers and now I've put on these button things that are there. I'm getting stared at like some. Now once again I'm testing the room, and then I'll be testing the listening position. Now the room as it is, I can kind of tell a difference in the echo actually. Slightly more echoey. Or I'm just talking crap. Okay, so apparently I can't finish a video, but I am redoing these tests in a different room. This is one of our live rooms, so I'm just I'm using Room EQ this time. Last time I was just using Pro Tools and Pro Q3 to just kind of see what the frequency response was. However, I can't really see a difference. There is a difference. I can see it slightly in like the levels. However, I want a really in-depth measurement of these acoustic panels. So I've got them set up just now. They're standing up actually. In fact, that's the standing mechanism I made for them. Basically, it's just two pieces of wood at the bottom. They're kind of flat out, and you can spin them round so that when you have it hanging up on a wall, in fact, I'll just show you. Basically, like this. You can spin in and spin out, so it can stand up and hang on a wall. So I'm going to have these in different formations. Right now it's basically just around the microphone like that, and then going to move it around the room to see if the response is any different. I've now done that reading with the acoustic panels, So now I'm doing one with the room. I probably should have started with the room, to be honest with you. I didn't, so now I'm just going to do the room as it is. And then I'll put the acoustic panels just around the place to see how it affects the frequency response. And now I'm just having these panels spaced around the room. Can't set this one up there, so I'm just having it in front of the drum kit. Yeah, it's not ideal, but it works. Okay, I won't lie to you. I haven't really got a clue how to read this. However, this is the panels that were in front of the microphone. It's in a half dome around the microphone. The decay is 582 milliseconds. And then without any panels in the room at all, the room just by itself is 622 millisecond decay. So it's a 40 millisecond decay difference, which really isn't that much at all. And the panels spaced around the room has a decay of 596 milliseconds. So this response right here is a frequency response of this room with no panels. This is with the panels in front of the microphone, and this is with the panels spaced. There is quite a difference in the low frequencies here. I'd say the main difference in these panels is around about 80 to 100 hertz here. And then you've also got some absorption up here as well, but there's the biggest difference here, around about 87 hertz. There's about a 4 decibel difference, 87 hertz. I didn't do the testing right at all. Like, I was way off with the testing. I like to think of what I've done as, like, I have put a napkin, basically, or like a paper towel, into a bucket of water. The acoustic panels were like a small dent in the acoustical properties of that room, the big live room. So I redone the tests, and the panels are much better than the test results from the last test showed, in terms of like frequencies absorbed and the decay time. The decay time shocked me, to be honest with you. I didn't realise it was going to be as effective as it is. I could definitely do things to these panels too that would make them even more effective. For example, the density, as I've said before, the density of the fabric was not, it was something that I should have tried to find a better density, a higher density for these panels. But the company that I was buying from didn't have an option for a higher density for that installation. So this is the results. This is the frequency response. This was done in an acoustically dead space. So this green line here, or turquoise line, is the room without any panels in it. And this is the room with panels. So there's a significant decrease starting from 300 hertz all the way up to 20 kilohertz. What I found was most surprising was from 1K, there is about a 10 or 11 dB difference. And at 600 hertz, there's a 6 decibel difference. Okay, so this is where it gets interesting, or at least I think it's interesting. This test was done in a corridor, a small corridor in from one of our live rooms to one of our control rooms. I decided to do it in the corridor because the space is really reflective, and as you can see, the decay time for this room is 1124 milliseconds. Now, with just one panel in the corridor, it reduced the decay time to 681 milliseconds, which is an almost 445 millisecond difference. With two panels, I found quite odd. There wasn't much of a difference at all. 672 milliseconds is the difference with 2 panels. 681 milliseconds with 1 panel, which I thought was quite strange. But with 3 panels, it's a 502 millisecond difference. Anyway, I'd like to say it's been a pleasure. For you, maybe. For me, no. Goodbye. Thank you for not paying attention.